There we go. So the interesting thing is when she turns southwest, right? So she goes 3 west, and then she goes 2 southwest. So from here, she goes 2 southwest. So then it asks, what is this? Because her home is at the origin, of course, right? Okay, so there's a few different ways you can do this. Do you guys see how this is really a, well, come on, does somebody see how to do this? So I've got this vector, and then I got this vector, and I want to know what this is. What vector operation is that?
Is it the magnitude?
Okay. The problem with that is you don't know what vector you're taking the magnitude of. So what I'm really asking is, how do you get this vector, which you can then get the magnitude of in the angle for, right? You got to first get that vector, though.
Wouldn't it be -3, -2?
Yeah, so this is 3 back. So you're right, this is -3. But how do I, what do you mean -3, -2? No, no, no. She's going 2 miles southwest. If it was 2 miles south, then it would have been, she would have ended up at the point -3, -2, sure. But she's going, do you understand? She's going 2 miles southwest, right?
So could we think of that one as like the slope almost, or no?
All right, in a way, but the problem is, and I think the person that just suggested -3, -2 understands this. If I find what point this is, right? If I find what point that is, then I could look at it like slope. I could get the magnitude. I could do the angle. I could do all that shit. How do I find that point? Which is really, how do I find this vector? So she starts at home. Here's a little house. And she goes 3 that way. And then she goes 2 that way. Let me do a little bit almost to scale. And so I want to know what this is here, right? I got to figure out what that vector is. What are these vectors doing to each other? What is this result? What is the vector algebra that I have to do? So here's vector u, here's vector v. How do I get this result? How do I get this?
Do you add them?
Yes. Now, that's where things get easy. Why do things get easy now? Because, well, not completely easy, but easier. I know what this vector is, right? This vector is -3, 0, right? Is that cool? Now I just got to figure out what would this vector be. And that one's not as bad as you might think. And there's multiple ways to do this, but this actually captures all the ways. The math would be the same. Stay with me now. Stay with me now. If I want to know, maybe I should do this on the board. I always hate trying to do this. Yeah, let me get up on the board. Screw this damn computer screen bullshit. All right, here we go. Let me spotlight this. Yay. All right. Oh, yeah. Move over there. Okay. Hold on. And someday I got to actually wash this thing. Whoop, whoop, yip, yip, whoop. Stay. All right. So I've got a vector. -3, 0. And then I got this vector. I want to know what it is. I do know that the length of it is 2, right? So if I want to know what that vector is, I'm going to put it at the origin to figure out what its name is. Is everybody with me? That's how I get the name of a vector, because the name of a vector is the point it would point to if it started at the origin. Does everybody remember that? Okay. Why is this one not that bad? Because what's the angle here? If I'm going southwest, what's that angle?
$45.
Yes, it's got to be 45 degrees. And so I have a 45 degree. This is 2. So I really just want to know what, holy crap and a half, Jeff. It's all right, dude. Doesn't have to be perfect. I got to know what this is and what this is. So there's a really nice way to do that. What kind of triangle is this going to be?
A right triangle.
Okay, right triangle. More importantly, it's going to be, these two angles are
45.
the same. So you know that whatever these are, they're the same. So therefore, you know X.
3.
Sorry?
Sorry, one of them's -3, right?
No.
Damn it.
Come on. I know
Oh,
this
no,
vector.
you're right. Okay, I got
I
it.
know that vector. Screw him. I'm trying to figure out that vector. So I'm going to move it back to the origin and figure out who it is. I like it. And this is not the only way to do this, but the math involved in this is the same as the math, whatever way you want to do this. So just in case you came up with another way to do this, there's a whole other way to do this too. But can you guys see now I can just do this? X squared plus X squared equals 4. So X squared equals 2. So X equals rad 2. It's not plus or minus because this is actually motion. Well, I can do negative. It doesn't really matter. The negatives you already got in there. Who cares? So this will be negative. So that vector is the vector negative rad 2, negative rad 2.
I don't understand how you set up the 2x squared equals 4.
Oh, all right. Are you cool with this little triangle here?
Yeah.
All right. And I could have done, I guess, a better job of representing this. I can do it off the x-axis. There we go. So this is the 45-degree angle. This is obviously 90. This is 2. And then I don't know what this is, but I know that these are the same because this is an isosceles. These are both 45. Is that
Yeah.
Okay.
Yeah.
You could also use trigonometry here. Ooh. Right. We could also use trigonometry here, but I don't really need to go that far. And then x squared plus x squared equals 2 squared leads to what I just got, the negative rad 2.
Oh, okay. Makes sense.
I love it. Kick ass. And now you just have to add the two together. How do I get this vector here? I just add these two together. So then let's call this vector W. Why not? So W would be -3 minus rad 2, negative rad 2, right? Adding these together. And now you can do the magnitude and you can do the inverse tangent to get the angle. Is that, you guys with me? Is that all right? It's okay if the answer is no, but just give me an answer. Are you still there?
Wouldn't you do the inverse of cosine?
No.
Yeah, the book was saying something about that, and I was confused because
Where?
all
Can
I
you tell me?
remember learning was the inverse tangent.
Of course. Where do you see this inverse cosine business?
Because it's cosine theta equals x over the absolute value of v.
It was on the book, like on the top of the book.
Top of the book. All right. What do you
Like,
mean?
you know where they teach the lesson?
At the beginning of section 10A. Is that what you mean?
Yes.
All right. At the beginning, all right, let me see. Okay, do you know exactly where it is? I need to see why this book is going insane. Does anyone remember where exactly it is? Because I don't see it at the beginning. Are you guys? All right. This is a weird week, I tell you. Do you guys remember where you saw that? Do you remember what context it was? Let me see if I can figure this out. Oh, are you talking about? No, wait a minute. No. You're not talking about this, are you? All right. Hold on, everybody. Are you talking about this stuff with the dot product? And doing the inverse cosine to find, where's their example? Here we go. Doing the inverse cosine to figure out the angle between the two vectors.
Yeah.
Okay. So, I feel better. I feel better and neutral. Okay. Guys, so let me make sure I didn't misread this question, but this shouldn't have said anything about the angle between the vectors. Which problem was this again? I love you guys. Which problem was this again? 61. Okay, I could figure it out eventually. I love it. Is that the approach? Are you taking my approach, my teaching approach, where it's the wait and see if they can answer the question themselves? Yeah. So in what direction must she walk to head directly home? Right. So it's you want to know at what angle she's got to walk to go back home. So if I can figure out, so I want you to see, if I can figure out what this angle is, isn't that equal to this angle here? That would be the angle with which she has to walk to get back home. So angles kind of tell me direction. So this is not a problem asking you to find out the angle between two vectors. That's the dot product inverse cosine stuff. Why is it inverse cosine? Because it was a cosine in the dot product formula. That's the only reason that's inverse cosine. What is this one asking for? It's asking for effectively the angle that the resultant vector makes. That's what it wants. And I understand it's the wording of it and you're not really sure what direction really means. I get that, but this is not asking for the angle between two vectors. That's when you would do the inverse cosine from a dot product. There's no dot product to do here. Are you guys, is that all right?
So then how would you find the angle for this one?
Inverse tangent. So any vector I have. So right now I've got this vector here. This is the resultant. So I have this vector and the other vector, and then this is the result that we got, right? This is the vector W, and I'll put it up here. W is this bad boy. Any vector I've got, how do I see how long it is? Well, isn't this length and isn't this length? So wouldn't I just do x squared plus y squared square root to get the length? And then to get the angle, isn't the tangent of theta equal to y over x? So I would do the inverse tangent. Right, so to get the magnitude would be this squared plus that squared square rooted. Are you guys, that's why it's the inverse tangent. Like I said before, it's a lot like conversions between rectangular and polar. It's the exact same conversions we used. But instead of r, we're now saying length of vector, which is basically what r means in this context. I don't know, is that better? Do you guys? I only do the inverse cosine dot product stuff if I have a problem saying, what is the angle between these two vectors, right? In a problem like this, it makes more sense if I'm talking about a boat like number 62, but on number 61, we're still assuming we do directions based on bearings, right? So relative to horizontal, what angle would I have to walk at to get back home? That's really what it's asking. So It's a very strange way to look at the world, but that's a way we could look at it. Is that all right? Is that better? It's okay if the answer is no. Just tell me what's happening.
Well, on the homework, I'm pretty sure we have to do that way because I just did it right now. And we have to do like the inverse of either sine or cosine. And I'm looking at the answer in the homework on the answer sheet. And that's the answer I got.
All right, so what'd you do the inverse cosine of?
Of x over the absolute value of w.
Oh, okay. All right, guys, you're killing me. Of course that'll work. I love you guys so much. Look, we're trying to get this angle. Agreed? We're trying to get that angle there. Agreed? So if you know this, then you could use cosine. Of course you can. But what's the standard way to do it for any given vector? Is to do this. Because then I can just see y and x. We do happen to know what the length of it is. So you could also do it. Do you understand? You would get the same damn thing if you did the inverse tangent of that over that. Because it really does it's just the right triangle now. Once you've got it like this, it's just the right triangle. So of course other things would work. All right. So what got me concerned is somebody said it was in the book saying that, and that part is about dot products and finding angles between vectors. If you want to do a different trig function, it's a right triangle. Who gives a shit? You could certainly use a different trig function for sure. But this is if I just told you a vector 4, -5, and I said, what direction is that? What's the angle? Well, I'd rather do that because then I could just use inverse tangent and -5 over 4, be done with it. I've got nothing else to calculate, right? That's why I go to that. But you're completely right. You're completely right. You could use any other trig function to figure out that angle because you happen to know all the sides of the triangle. Is that all right? You guys all right? Okay. All right. So hopefully you understand the reference to the book and the fact that that was the dot product problem that the book talked about made me worried that you guys were putting those things together, but it's just the right triangle.
So for
Go
the
ahead.
dot product, if you're trying to find the angle, that's when you use the cosine of the answer that you get?
Inverse cosine.
Of the
Yeah.
answer that you get from the dot product? Because
Not.
but in the homework we didn't have to
No.
do anything like.
Huh? Sorry.
Never mind.
So they didn't ask you to do any. I thought for sure there was. Let me see. Yeah, they might not have asked you any of that. Man, that sucks. Yeah, on first blush, I don't see any that necessarily ask you. Well, that sucks. Why did they put all that in there? I love that stuff. Find the angle between two vectors, but I don't see any problems in here. All right. Shoot. I don't know why they didn't make you calculate the angle. Yeah, so it doesn't look to me like they did ask you to calculate the angle between anything.
So could you do like one just in case it's on the quiz so we know how to do it? Please?
Yeah. Well, I'm going to say this. If they really didn't put any of that in the homework, I'm not going to put it on the quiz. Does that make sense?
Yeah.
Yeah, because I don't like giving you quiz problems. That's not really in the homework. I'm just kind of bummed out. I didn't realize they didn't give any problems like that. Oh, well. That sucks. Oh, well. if you're going much further in math, you'll eventually get to a point where you're doing a lot of vector stuff. So that's going to become huge. All right. Yeah, they don't do that at all. There was something else I was going to say and I forgot. All right. All right. Anything else, guys? Anything else from homework stuff? Any more of those vector questions? If you see how to do number 61, that should definitely help on pretty much all the ones after that, possibly. You do start getting stuff where she starts walking in multiple directions. That might drive you a little insane. So let me give you an alternate way to do a problem. Let's look at one of these problems. Let me give you this alternate way to do this. So look at number, I don't know, 64, where she just starts going crazy. I feel like she's the creature from It Follows. That's why she's able to just go in these straight lines. If you've never seen the movie It Follows, that might be better. So look at this, 4 miles east, 7 miles southeast. Let me write this stuff down and then you guys do it too. 4 miles east, 7 miles southeast, 6 miles south. Holy shit, this is all the same problem. It's 5 miles southwest and 3 miles east. Woo! All right. I think that's do it. Okay, now stay with me. I think I got all of it. 47653. 47653. Yeah. All right. Hopefully I got all the directions right too. Okay. Now here's a fantastic way to do multiple vectors. This will drive you insane. Don't try to draw this shit. You will go slightly insane if you draw this shit. Notice these are the two best ones up. Well, there's 3 really good ones. These two go together really beautifully. I can condense these into 7 miles east. Is that cool? That's the first thing you look for. And hopefully I didn't. Was that all in the same problem? I really feel like I might have. East. Yeah, cool. All right. Thanks, problem. Very nice of you. Is everybody with me so far? That's the first thing to look for. Does anybody work together? And then you have this guy. He's kind of nice, but he's not going to go really directly with anybody else. And then you got these two that are the worst, right? Because they're going to be at angles to everything. So let me write this over here. So I've got it kind of grouped up. So I've added together what I could, and I put the next best thing there, and then I put the 2 worst things there, just because. Okay. This has components. So if I could take this guy, 7 miles southeast, just look at him alone. Southeast, so that means 45 degrees, right? And that's 7. So you don't try to draw all the vectors on top of each other. Holy shite. Can you tell me what the components of that are? Does anyone, here's the quick, now watch this, guys. Watch this. Let's do, I know somebody out there has to know this. If I have a 45-degree triangle and my hypotenuse is C, what will these be? Well, these will be, stay with me now, stay with me. This is going to become everything I know somebody out there knows this. This is a basic thing from geometry. This will be 2x squared equals c squared. Is that cool? Right? X squared plus f squared equals c squared. So x squared equals c squared over 2. So x equals c over square root of 2. Okay, I like it. So this will be This will be 7 over rad 2, and this will be 7 over rad 2. And real quick, that one we had earlier, that was 2. Remember, it was 2. Didn't we get rad 2, rad 2? Why did we get that? Because what's 2 divided by rad 2 is rad 2. I don't know if you guys are with me or not. So every 45-degree triangle works like this. If you know the hypotenuse, the sides are the hypotenuse divided by square root of 2. Why does that work? Because this would be 49 halves plus 49 halves is 49, which is 7 squared. Bam, done, 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 right? If I square both sides and add them, I get the hypotenuse. Yay! You guys with me out there? So look what I could do to this then. And again, you don't have to do it this way, but this is definitely a nice way to do this. I can rewrite this as 7 rad 2 miles, what was this, east, and 7 rad 2 miles south. As that goes, that's what this means. 7 rad 2 miles east, 7 rad 2 miles south. And there's multiple ways to do this. Oh my goodness. All right, I'll show you the other way. There's another way. Now I take this other thing here. I'm going to do the same thing. And of course, you guys should already know. If I do everything I just did, how many miles south and how many miles west? This is 5. If I do everything I just did when that was 7, what am I going to get here?
5 divided by rad 2.
5 rad 2, 5 over rad 2. All right, now I've got more like terms, don't I? I don't know if you guys are really with me. And some of you guys who are more mathematically minded, which is kind of funny. I'm a math teacher, but I sometimes do math problems less mathy than other math people. But there's a much more mathy way to do this. And I'll kind of show it to you in a second. So let me cross these out, right? I took this one, broke it up. I took this one, broke it up. And now don't all my easts, how many east and my west, can't I put those together? I really want you guys. So what do I got going east? I got 7 plus 7 over rad 2 minus 5 over rad 2. Are you guys cool with that? Because isn't that west? Isn't that negative east? Right? I don't know if you guys are cool with that. I don't know. Wouldn't west be the negative direction if I'm doing that? Right? Okay. So that's east. That's these guys. East, east, and west. And then everything else is freaking south. They just all add together. So that'll be south will be 6 plus 7 over rad 2 plus 5 over rad 2. Shaboop, shaboop. So then what is this vector going to be? It's going to be 7 plus 2 divided by rad 2 is rad 2. Are you guys okay with that? And yeah, this is south, I know. So 6 plus 12 over rad 2 is going to be, you could do it, Jeff, 6 plus 6 rad 2, I think it is. I don't know. 6 plus 12 divided by rad 2. Yeah. Okay. So this would become 6 over rad 2. I mean 6 rad 2, what I just wrote. Now, be careful. I could make the, I get, this is going to be negative because it's going south. Is that cool? I'd make it negative because it's going south. Is that all right?
Yup.
Okay, okay. I have no idea if you guys are like this. This is less purely mathematical. It uses some math, obviously, but then you've got like, you're just putting together the things that go together. If you can break every vector down into purely one of the 4 cardinal directions, you can put those together. If they're working against each other, you subtract them. If they're working the same way, you add them. It's crazy. That's exactly what vectors do anyway. So this is the same math we would do if we made them all look like vectors. It's the same stupid math. Now I could do everything I need to. I could figure out the length of this. I could figure out the angle this makes. Maybe. Is that cool? Now I can just do the length of this would be the square root of this squared plus that squared. You could do that in the old calculator. And then you could do the inverse tangent of this divided by this. You could do that in the old calculator. Maybe. Now, in case you want something a little more mathy, let me take this away. You could, let me see, 7 miles east would be 7, 0, right? For 7 miles east. 6 miles south would be 0, -6. Are you guys with me? I could have made them look like vectors earlier, is what I'm saying. It doesn't matter. I make it look like a vector here, or I make it look like vectors at first. Because then I can just add them together. 7 over add 2 miles east would be 7 over add 2, 0, and so forth. And then you just add them all up, and guess what you get? You get this shit. It's the same thing. It's the same math. All right, so you have an option. You can make it less mathy, or you can make it more mathy. Totally up to you. Whichever way makes you feel better. If you feel equally bad both ways, then just flip a coin and do whatever that comes up on. And if the coin lands on its edge, play the lottery. I don't know, something. All right, anything else, guys? I think, did I miss something? Somebody asked me a question in chat a long time ago, and I'm sorry. I think, oh yeah, that's the question we're working on right now, right? That section. Okay, I think that jived with somebody else, so I got lucky on that one. Anybody else? Anything else, guys? I'm glad several people are in the vector section. That is very good. I don't know why I'm talking to you like that. It's really good that you're there. Okay, nothing else? You guys are all right otherwise? I don't know if you guys noticed. Did anybody notice I put a practice quiz up there for quiz 11 that's going to happen on Monday? So, you know, you don't have to tell me if you notice, because now everybody knows it's up there. So hopefully over Thanksgiving, I'll get the video up there, right? Ooh. I can't remember now if I put a find the angle thing on there. Let me see. If so, that would be something I would take off of there. Here, let's all look together. Shit. Oh, good. Okay. Oh, no, you did go there. I don't want to go there. All right. What am I looking for? I have forgotten. Oh, yeah, the practice quiz. Condense. No? All right, here we go. Unit 10. I put it in Unit 10 because it's a quiz on Chapter 10, so hopefully that doesn't throw you guys off. Practice quiz 11. Let's see if I put a find the angle between the vectors thing on here.
Wait, did you say
Oh, I
quiz
did.
11 is on Monday?
Quiz who?
Quiz 11?
Yeah, it was supposed to be today, but I moved it to Monday.
Isn't it Chapter 10?
Yes, but remember, quiz number 10 was on the first part of Chapter 10. Quiz 11 is on the next part of Chapter 10.
Oh,
so my
quiz 11, not Chapter 11. Yeah. Okay, sorry.
I didn't want to have a quiz 10A and a quiz 10B.
I thought it included Section 11. I thought you meant Section 11.
Chapter 11? No. All right. Sweet. And then I kind of give us a break from quizzes. All of this stuff, of course, will be on the final, right? But I figured, you know, I could give us a break from quizzes in here. Let me see. Okay, so let's stop doing this. Anything else, guys, from 10.4 through 10.8? That's what the quiz is going to cover on Monday. Okay, all right. There are multiple ways to do these problems. almost every time you figure out a new way to do something, it's the same math, just in a different order. So it's all good. So we're going to get back into where we left off, which was using matrices to solve systems of equations. So what I've done, I've created a problem. I don't know how ugly this is going to be. Let's find out together. And I'm pretty sure it works. We'll find that out together also. And I'll tell you, one of the suckiest things about these is all it takes is to forget one negative sign and the whole thing goes to shit because it's all interacting with each other. So the minute you leave out one negative sign anywhere, you're dead. Now, I don't say that to make you feel discouraged. I say that to remind you that you have a teacher that gives you partial credit, that doesn't just base how many points you get on your final answer. That is complete bullshit. If I can see evidence that you know what you're doing, you know the process, and I go, oh, you left a negative out there. Shit, that's why you kind of lost it down here. I'll give you most of the points. Right? So if you're running out of time and you're going, just try to get as far as you can and just show me you know what the hell to do. And then I will find where you made a mistake and I'll figure out how big of a mistake it is. Does that make sense? All right. This is why you don't use Scantrons with me. How could can you take a second and write that as a matrix? Do you guys remember how to do that? Oh, all right. I'm so happy I like double checked this. So how you guys doing? You right? Do me one favor. Let's make this 0, make it an 8. All right, so let me catch up to you. So a matrix is sort of the same idea as synthetic division. It's not the same process, but the same idea. The letters are unimportant as long as they're in the right place. Just like with synthetic, the letters are not important as long as they're in descending order. Right, so then I could forget the variables. It's all about the numbers. So let's see, 3, 1, -1, 8, -2, 5, 2, -21. To be honest, I don't even know. Does this book use that line? I don't even know. 4, -3, 1. It might not use this line, but I like this line. It just keeps me visually certain about where shit is, and that's the equals place. So that's, I don't know, I just like it. What kind of sucks about this? Remember, can you guys remember, do you remember what the goal is? What's the goal? I'm going to do some shit to this. What do I want to make it look like?
One's going diagonally across.
Yeah.
And everything else 0.
And then here will be the answers. And like somebody pointed out yesterday, it doesn't really matter what order these are in, as long as you have the one first, the one second, the one third. It doesn't matter what order they end up in. It's fine. So what kind of sucks about this? This is going to be neat. This is going to be like a choose your own adventure math problem. Because I'm going to suggest some things and then I'm going to see what you guys want to do. So do you remember what we did yesterday? Didn't I have a 1 here and I started killing stuff? Do I have any 1s in the first column? So here's 2 suggestions. I can either just start on a different freaking column, right? So if I pick a column, get it completely done. So you're not doing the whack-a-mole thing. If you start jumping amongst and just start doing this one, and then you see this one, and then you do that one, you're going to invariably start losing zeros. Why are zeros the most important things in matrices? Why is a 0 the most important thing? Anybody? Why is a 0 the most important thing? What is the motivation for how to solve a system of equations? What am I trying to do?
Eliminate variables
by itself.
Yeah, I want to kill these variables. So if I get a 0 in the matrix, it's equivalent to killing that variable in that equation. You guys with me? So ones are sort of important. They're not completely necessary, but they're nice when I have them. Zeros are the goal. Zeros are the goal. So for example, what if that was a 7 and that was a 0 and that was a 0? I would just freaking divide by 7. So that's why ones are sort of kind of nice, but they're not completely important. So let me give you 2 suggestions. I could either start on a different column because these have ones in them. Or is there a way I can make a 1? Can I just add these together and make a 1? Does somebody have a preference on which way they want to go with this? Do you want to start with a different column, or do you want to force a 1 to show up in the first row?
Do the first row.
Okay, all right. So if I take row 1 plus row 2, and I'm going to put the answer in row 1, because then I can have the 1 where it belongs. Does that make sense? Okay. So let me do that. So this, you're not only writing this for yourself, you are writing this for the person grading your stuff. Please, dear God. If you just have matrices kind of all over and stuff's out, I'm like, what the shit happened? What did you do? And then for yourself, you're like here and you go, what did I do over here? And if you don't write this shit down, you're like, I don't know what the hell I did. What the shit? So let's be nice to each other and ourselves. Oh, okay. So if I add row 1 and row 2, I'm going to get 3 minus 2 is 1. 1 plus 5 is 6. Negative 1 plus 2 is 1. 8 minus 21 is negative 13. Become a negative 13. Is everybody with me so far? Nothing major has happened yet. I would normally do more than just that, but let's go ahead and do a little more work. I'm going to try to do 2 steps at once now. Can you guys see something? Well, let's see. Why is it good that I have this 1 here now? Why are 1s so nice? Because I can multiply them to become anything I need them to be. But do you see how these will play off each other too? How would I kill that 4 using this?
2 times the second row.
Yeah, multiply row 2. So take twice row 2 plus row 3. Put the answer in row 3. Is that cool? All right, we're going to see if you guys can handle this. This is going to be a good demonstration of the way you can shorten the length of these problems, right? To get the full utility of these freaking matrices. How could I use this to kill this? Because after I do this, I'll have a 0 here, won't I? How would I get a 0 there? What would I do? I'd basically do the same damn thing, just twice row 1 plus row 2. Is that cool? So I tell myself what the hell I'm doing, where I'm putting the answer. What the hell am I doing? Where am I putting the answer? And what's guiding me on where to put the answer? Well, technically, that's why you want to follow this. So you always kind of know where to put the answer, but generally it doesn't really matter, just whichever place is best, which is hard to explain until you do more of these. All right. So let's see if we can handle all this shit. You ready? So here's what I do. I'm going to do this first. So twice row 2. Really, Jeff? I don't know, Jeff. I don't know if you know if the colors show up differently for you. So twice row 2, I'm going to put negative 4, 10, 4, negative 42. right? So that's double row 2. And then I can add it to row 3. So then I get 0, 7, 5, negative 42, and 26 is negative 16, I think. Yeah. All right, let me stop for a moment. The math in these is so beautifully not difficult. It's just the way we set it up that you have to get used to. And I other teachers don't do this shit. This is me. I don't want to rewrite the damn matrix to make this show up for a second and then I divide it to go back to that. Why would I do that shit? You're done now. Go away. I'm done with you. You did your job. Thank you. Get out of here. And now I can do this. Twice row 1. All right, let me do twice row 1. 2, 12, 2. Hopefully that's right. And, oh yeah, negative 26. Yeah, okay. And then I can do that plus row 2. So then I get 0. Please yell out the minute I lose you. 12 and 5 is 17. 2 and 2 is 4. Negative 26 and negative 21 is negative 47. Crazy sauce. And then the first row is the same. Now, all right. And you basically repeat the same process, but now you move to this next column. Let's do this. All right, let me show you a couple things. Why would I not want to try to use this one to kill these? Why would that be bad? What at the same time would I be doing? So if I like multiply row 1 by negative 4 and add it to this row, what am I losing?
A 0 and a 1.
Yeah, holy shit. So I cannot use row 1 to kill anything here because I'm going to lose a 0. Do you guys see? But now these rows can kill stuff in row 1 and not screw with that at all, right? Their zeros won't screw with that. Do you guys see that? Sure, Jeff. All right. So here's my suggestion. Do you see another way I can make? So there's 2 ways you can do this. You never need a 1. You never really need a 1. Couldn't I multiply this row by 7 and this row by negative 17 and that would kill these? Do you guys understand what I'm saying? If I multiply this by 7 and this by negative 17, these would die. Do you really want to do that? I don't. So that's a good motivation. It's not always this easy, but this is kind of lucky. Can't I make a 1 right here if I just subtract row 3 minus row 2? Are you guys, do you understand? 1s are nice. 1s are not necessary, but they are definitely nice. They make things much, much easier. You don't need to. Do you want to try an example where we don't get a 1, where we work around it? Do you want to do that right here? Or you guys are like, I don't care, man. Just freaking do something and make this done. Please make my turkey day start. I'm sorry. Stay with me now. Stay with me now. So let me go ahead and do that. Let me go ahead and do that. So I think you guys see, you could, if I took row 3 minus row 2, I could make a 1 here, and then I could use it to kill shit. But now watch. Let's do this a different way.
Just a really quick question on that.
Yes.
Let's say we did subtract row 3 from row 2. Would that be the new row 3?
Yeah.
Because that's where the 1 would be.
It wouldn't really matter, but you're right. In order to keep the goal going, I could put the result here.
Okay.
So if you want to see that, we could do that. I don't know what you guys want to see. We've already kind of done that once. I don't know. Maybe we could do that because the other way I was going to do this is multiply this by 5 and this by -4, and that's going to be gross 2. So let's go ahead and make a 1 here. Why not? So let's do, what do we got here? Row 3 minus row 2, put the answer in row 3. So 1 stays the same. 2 stays the same. And then 3 becomes 0, 0 minus 0, 7 minus 17, 5 minus 4, -16 plus 47 is 31. Hoochima. And now I can multiply this by -4 and kill that. You guys see that? And then I could just multiply this by -1 and kill that. You guys with me a little bit? I have no idea. If any of you are out there, you're like, no, I just watch this show later. I log in, go somewhere else, and I watch this show later. Okay, whatever works. So now I can do, like I said, I can do -4 times row 3 plus row 2 and put the answer in row 2. So -4 times this will make that -4. Added to this guy, put the answer here, so there'll be a 0 here like I want. So the less comfortable you feel about what's going on, the more you stick to that. That's your game plan. That's your goal. That will keep you focused. So if I do -4 times row 3, I'll get 0, 40, -4, and oh man, you sucker. Let's see, -124. It's looking yummy. All right, Jeff, let's see what happens. So 0 plus 0 is 0. 40 plus 17 is 57. -4 and 4 is my 0 I wanted. -124 minus 140, minus 47 is -171. Please tell me. Yes, right? 57 goes into 171. And then they go in 3 times, right?
Yep.
Thank the gods. All right. We'll do that on the next step. Now, what I could, at the same time, so let me cross through this shit. I'm done with this shit. I crossed through it. It did its job. I crossed through it, or even I erase it. Whatever you got to do to keep yourself straight. What can I do to make a 0 show up here? I'm going to multiply this row by negative, yeah, -1. And then I can add it to row 1. So it'll be negative row 3 plus row 1, put the answer in row 1. So I think you can handle it if I just do it. Bam, bam, bam. So now I get 0 plus 1 is 1. 10 plus 6 is 16. -1 plus 1 is 0. -31 minus 13 is -44. That's nifty. And then I get the bottom row stays the same. All right, I can keep it like that, sure. Okay. And I know you're all out there going, this is one problem, sir. I don't blame you. But of course, I can't remember. Hopefully I didn't assign too many of these. If you think that, well, everybody thinks I did, no matter if I did or not. But, you know, let me tell you this while I'm thinking about it. I'm pretty sure I'm going to look into the next sections. And obviously, we're not going to get through all of 12 or 13. And I think I'm going to try to cut down on some of the homework just so it's because we're going to do, you know, just because it's the end of the frickin' semester and there's a lot left to do. So anyway, so look for that. Now I can divide this row. Is that all right? Are you guys going to freak out if I just do it right here? 57 goes into -171, -3 times. And then, of course, what's beautiful about that, I have a 1 right here. Do you see why I call this row the laser? It's a laser. It's not going to, I almost said fuck. It's not going to screw with this. I did say 5. It's not going to screw with this. It's not going to screw with this. It's just going to mess with that one piece. The one piece that I want to die in the other things. It's exactly like a laser going after a tuba. Oh, I see. No, I'm not changing chapter 11 homework. Don't get too excited. I don't think.
Damn it.
Sorry.
Oh, sorry. I thought it was muted.
12 and 13. Yeah. All right. So now to kill this, to finish this thing off, just let me do this real quick. It would be if I multiply this by -10, I can kill this guy. And if I multiply this by -16, I can kill that guy. So if I do it by -10, I can kill the 10 right below it. So then it would be 0, 0, -1. 30 minus 31 is -1. And that looks beautiful. And then, is that all right? I'm just going to erase that, right? You can just erase your pencil markings. And then if I multiply this row by -16, I can kill this thing. Die. -16. That was a little too intense there, John. I don't care. 16 times 3 is what? I don't know, 48? Does that sound right? Okay. 0 and 1 is 1. -16 and 16 is 0. 0 and 0 is 0. 48 minus 44 is 4. And then the middle row is still 0, 1, 0, -3. So there's the answer. 4 is x. X is 4. Y is -3. Oh, shit. Change the signs of the last row. Z is 1. Yes, a little long, not difficult, just long. And what's exceptionally cool about this process is, like I showed you, you can, let me show you. I'll show you the same problem in the calculator, right? Where you push a couple buttons and you're done. So you can check your work, kids. I think you've met me before. You know that doing your work in the calculator is not doing your work. I still have stat students who are like, I pushed this button and that was fine with my last teacher. I'm not your last teacher. All right, sorry. I got to vent some frustration. Let me see. Oh yeah, I need my calculator. So if you guys remember how to get into your matrices in your calculator, go ahead and stick this matrix in your calculator and smoke it. No, just stick it in there and let me see. Come on, calculator. There you are. Let me show you in case you forgot or you weren't here. So if you go to second, this button right here, that's matrix. I've got a couple matrices in here already, but let me edit this one. I need to make it, how big is this matrix? What's the dimensions of that matrix?
3 by 4.
3 by 4, I love it. 3 by 4. Bam. And then I can just put this shit in here. Let me see. Can I do it like this? Yes. Thank God. 3, 1, gallery, -1. Ah, scheisse. It's the wrong negative. You jackass. Bam. Where am I at? 8. It sucks. Might as well just do it all in here. -2. 5, that's nice. So this process, if you are at all aware of programming, this process is utterly programmable. It is very programmable. That's why it's so scalable, no matter how big the matrix gets. Now watch this. Here's the weird shit. Here's the terms I haven't used yet. How the hell do you make the calculator do to this what we did to this? So first off, do this. Never forget. Second, quit. Hit the mode button. Quit. Get the hell out of your matrix. All right. Now come back into matrix. And the thing we're going to use, what? I don't know how tense works anymore. The thing that we will be using now is called row-reduced echelon form. So does it make sense we're kind of reducing this matrix? Would that not be perfectly great to say that, but it sort of applies a bit? And it doesn't matter if it doesn't, if you don't think so, because that's exactly what we're doing. We're row reducing this matrix and we're putting it in what's called row reduced echelon form. So if you go to math and you scroll down, you're like, I don't see any row reduced echelon. Oh, there's RREF. Right. So if you go to matrix, Jeff, there is no spoon. And you go to math, go down to row reduced echelon form, RREF. And then you go back into matrix. All the matrix stuff on this calculator is annoying. And you pick your matrix A. I just hit enter for A. And look at that shit. And again, it's because and that was quick. It's so easily programmable. Is everybody okay out there? Anybody have any issues with that? So even if I had to do it by hand, if I added 3 more variables and 3 more equations, this process would be a little bit longer, but can you even start to imagine if I try to do this problem with 3 more equations and 3 more variables the way we did it in section 11.2, where we picked a letter and killed it, and picked a letter and killed it, pick a letter and kill it. Oh my God. So the matrix is so upscalable. It can handle larger problems without growing exponentially or growing very quickly. So we can't talk about the growth factor of this algorithm based on how big your problem is, but we won't. I think you get the idea. Okay. Maybe. So that's really nice that you have a direct way to check your work. And what's really, really, really nice, let me show you. What is really nice, Jeff, when you forget where you are? Oh, yeah. Let me just change. Now watch this. Get out of there, Jeff. Let me do this real quick. I don't know if this is going to work exactly like I want it to. Let me change. If I change one piece of this, if I just make this a 3, watch what happens to the answer. Let's see if it, yeah, look at that. Oh, yeah, that's an example of how horrible things can get if you make one mistake. But let me see if this does anything. This might not do anything. This might be very anti. Oh, look at that shit. Would you look at that shit? Would you look at that shit? Is anybody going, what? Do you guys know about that to fraction, that math to fraction? So it can handle entire matrices. I mean, that's pretty nice. Gross. All right. I don't care what you say. That is pretty. Which one's prettier, this one or that one? Come on. Somebody likes the first one better? All right, whatever floats your boat. You know, you're wrong, but it's okay. All right. What time you got? Oh, we got some time. Sweet. You guys don't like that, but it's too bad. Fantastic. Where are we at? Oh, yeah. Okay. All right. So here's something kind of nifty. Given a matrix, is there another matrix I can multiply that by and get something I would identify as 1? Right? So for example, with numbers, let me see, let me bring myself back. What number do I identify as how do I want to say this? What number do I identify as the multiplicative identity? Do you guys remember? Multiplicative identity. Does anyone remember what that is? What do I multiply something by to maintain its identity? Let me make that even more English. What do I multiply by to keep something the same? 1. So the multiplicative identity is 1. Can I multiply 4 by something and make it become the multiplicative identity? What do I multiply 4 by to make 1?
1/4.
Yes. Isn't another name for this the multiplicative inverse, right? Isn't that the inverse of 4, the multiplicative inverse? Are you guys semi with me? Matrices are like numbers. They are component things like numbers are component things. So watch this. This is kind of nifty. Let me first prove to you that what we identify as the identity is for 2 by 2 matrices, it's this. If that is supposed to act like the identity, if that's supposed to be like the one vector, the one matrix, the one, do you understand? Now you start to understand why math people got a little extra kick out of that crazy ass movie, right? The matrix, because the one, so the one matrix is this matrix and blah, 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 binary, hello. Anyway, sorry. Stay with me. How would I prove that this is one, the one matrix? How would I prove that? Well, what is it supposed to do fundamentally? What is one? Why is one times 7 is 7? So it's the number that I multiply something by that keeps it the same, which is why the word identity makes sense. It doesn't change something's identity. So how do I check this? Well, give me a matrix. Give me a 2 by 2 matrix. Any 2 by 2 matrix. Give me 4 numbers is what I'm saying.
1, 8, 5, 9.
I like it. All right, let's multiply this out. You guys remember how to multiply things? 1 times 1 is 1 plus 0. Do you guys quickly see how this is going to work? 1 times 8 is 8 plus 0. 0 times 1 plus 1 times 5 is 5. 0 times 8 plus 1 times 9 is 9. Did it stay the same? Yes. So isn't this basically the one matrix? My name is Neo. All right. Where's Morpheus coming? I don't know. Stop it. I don't know. So it kind of makes sense then that given some matrix, let me see, is that going to be a decent? No, it's going to be gross. Let me give us one that's a little bit less gross. Yeah. Something easy. 2, 3, 5. Okay. Given some matrix, there should be another matrix I can multiply it by that will give me, or there might be, let me say it like this, there might be an inverse matrix so that when I multiply it, Jeff, there we go, buddy, I get 1, 0, 0, 1. I get 1, just like there's a inverse number for 4. Is there an inverse for every number? Is there an inverse for every number? No. Which number has no inverse? 0, right? It's the same number that always gives us trouble. It's either in negatives or 0, right? So there could be matrices that have no inverse. And then, of course, they are special in some way. Sort of like the number that doesn't have an inverse is definitely special in many ways. Good old 0, right? Okay, so how the shit do I determine what this matrix is to make this work? So let me give you a gross way to do this, and then we might, well, let's see, we might run out of time. So here's the gross way to do this. Do we know what this is? No. So then we have to give it a variable name, which actually means we have to give it 4 variable names. But no, stay with me. Do you see how I have a matrix equation? Will this freak us out? Of course it won't. Of course it's not going to. Because what do I do to this to get 1? How do I multiply these things? Isn't that 2a plus 5c? Isn't that 1? All right, stay with me. And then 2b plus 5d. That's supposed to, 2b plus 5d has to be what?
0.
0, I love it. And then a plus 3c is 1, and b plus 3d is 0. I like it. This is a little bit freakadelic, right?
Isn't A plus 3C 0 and B plus 3D 1?
Oh, I got that. All right. Thank you, thank you, thank you. Good Lord, Jeff. A plus 3C. Yeah. Oh, that would have sucked. Thank you. Please call me out, especially at that moment. That's fantastic. Over there would have sucked. Okay. How do I start to do this? Well, what does this one tell me? These two are nice, sort of, but this one is especially nice. This one tells me A equals negative 3C, right? You with me? You guys with me out there?
Yeah.
Yeah. Okay. And don't I have another equation that has A and C in it? So can't I just plug that in and figure it out? So this would be twice negative 3C. So negative 6C plus 5C is 1. So C comes out to be negative 1. Is that, you guys with me out there? So I know what C is. So now I know what A is. A is 3. Now listen to me. We're not going to make this the way we do this. We're just doing this once. This is the long ass way to do this. There is a shortcut. But I just want to show you where it's kind of coming from. Now I can do the same thing with these two, right? 2b plus 5d and b plus 3d, right? I can actually even do elimination if I want to, but here I know that b is 1 minus 3d, right? I know that. Let me write this better. A equals 3. Okay, so that's what we know already. I know b is 1 minus 3d, so then I can rewrite this as twice b plus 5d equals 0. All right, this isn't really difficult, right? 2 minus 6d plus 5d, so 2 minus d is 0, so d is 2. And that means that b must be 1 minus 3 times 2, b must be negative 5. So let's put this together then. Our inverse will be 3, negative 5. Where'd you go? Negative 1, 2. Can you guys see any relationship between these two? What seems to have happened with these two?
They switch places.
They switch places. And what seems to have happened with these two?
They're both negative.
They're both negative. There is one extra piece to this that I knew we wouldn't have enough time to get into fully tonight. But I purposefully made this nice. I don't know if you guys realize when I wrote 2 and 3 first, and then I wrote 1 and 5. I was trying to make this come out nice. Because given this matrix, the inverse of this matrix, so this is A, the inverse matrix will be, let's see if we can capture what happened here. I'm going to leave a little room here. There's going to be something out front. It will be DA, see the A and the D switch, just like we saw happen here. The A and the D switch. And then the B and the C become the opposite sign. But there is something out front. What's out front is this freaky ass thing. Become an AD. What is A times D minus B times C in this matrix? 2 times 3 is 6. Minus 1 times 5 is 5. 6 minus 5 is 1. So I forced this to come out nice. So if I have any 2 by 2 matrix, that is a remarkably simple formula. So what about a 3 by 3 matrix? That gets a little bit worse, you might imagine. And that, I think, is where we'll leave it for now. Okay. So hopefully, let me think, what was it I needed to do? I feel like there was something I was supposed to do. Oh, yeah. Update the homework sheet. So I got to do that. Let me see. I feel like there was something else. Oh, so that's it for tonight. That's plenty. Let me know if you need to hang out. Otherwise, get out of here and try to have a decent, whatever it turns out to be, the rest of this week. I'm gonna grab some. I'm gonna make some pumpkin bread, so I feel
You're gonna
semi-normal.
make some pumpkin pie.
Sweet, fantastic.
Have a good Thanksgiving.
Thank you.
Take care, guys.